Thursday after. We're finishing up optimization. United States Postal Service charges more for boxes whose combined length and girth exceeds 108 inches. Maximum volume of a package with a square cross-section that does not exceed that 108-inch standard. Let's call that Y. Square cross sections means both the depth and the height will be the same value. Call it X. What are we trying to find the maximum of? Why? Right, we're trying to find the maximum of the volume of the box. Base times depth times height. Constraint.
Given our current variables x plus y has to be less than 108. Less than or equal to?
How did you get just X?
Well, it said length and girth, so I imagine that didn't include the height.
So what's girth?
I think another word for that is width.
do agree with a y. Plus. Girth is how much around? In this case would be 4x. That's why being a square cross section is so important. And yes, you're correct, less than or equal to 108. Since we don't want to exceed, we're just going to say maximum of 108. So we'll say equals. Right, because clearly, if we use the maximum allowed for the standard, that's going to maximize volume. Y is probably the easiest thing to solve for here. That should be x squared, sorry. So that's x squared and x cubed there. There's volume. And that's what we're trying to maximize. Derivative.
$216x minus 12x squared.
Actually, before I continue with that, domain for volume. So what values can x take on?
Any real number.
Could x be -5?
Okay, not for volume, so. Well, whatever the maximum value is where the first term is still bigger than the second.
What is it?
Yeah, what's it?
Between 0 and 27.
Why?
Well, like, length can't be negative, and it has to be 4x has to be within 108.
Yeah, because y also can't be 0. So if y is 0, 4 times x would have to be 108. Then 108 divided by 4 is 27. So anywhere that is undefined, set equal to 0 and solve. So that gives x is 0 or 216 minus 12x is 0, right? X can't be 0. x is 216 over 12. At a minimum, they're both divisible by 3.
X equal 18.
That sounds right. Too lazy to do it in my head. That sounds right. I'm going to go with that. Now we just have to determine if that does indeed result in the maximum. Second derivative.
-16 -4x. Negative.
Negative second derivative at a critical point means that critical point results in what?
Maximum.
Results in a max. And it's the only critical point in our domain, so it is an absolute max. And it wanted maximum volume. Two ways. You can plug it back into v of x, or we can determine what y is and then do y times x squared. Doesn't matter. What do you get when you do either one? I don't care which one you do, just tell me what the maximum volume is.
11,664.
What?
Inches.
What was it?
Cubic inches.
I don't like that. Convert to cubic feet. Because I said so. Six 6.75 cubic feet. Bless you. Physics problem.
Physics.
So a woman throws a stick into a lake for her dog to fetch. Stick is 15 feet down the shoreline and 30 feet into the water from there. So dog can jump directly into the water and swim, or run along the shoreline to get closer to the stick before swimming. We're told dog can run 22 feet per second and swim at about 1.5 feet per second. Question is, how far along the shore should the dog run to minimize the time it takes to fetch the stick? So that's about where we're at. So let's try and represent this. You know, that whole distance is 15 feet. Let's call this tiny distance up there, which is the distance the dog's going to run along the shore, X. By the way, we know that that is 30 feet. Let's call that the distance the dog has to swim, S. We are trying to minimize time. What is the total time going to be?
E would be X plus S.
Hmm?
Wait, no, X times 22 and X's and S's in there.
Definitely agree. There's X and S.
X divided by 22 plus S divided by 1.5.
Two of you should be ashamed of yourselves. Call yourselves physics people. Think this is week 2 of physics? It's not even kinematics, it's just basic motion. What's the restriction? Or in this case, the constraint. It's an implicit constraint.
The only thing I can think of is, X and S can't be above 15, 30 feet. I don't think that's going to help us.
Can't they?
Well, yeah, you can run past the ball short if you want to.
Well, that would be larger than 15.
Yeah, but the point is, if it is, that's not very effective. Maybe we can throw a theta in there and maybe we can string that somehow. No.
Why did you think theta, though?
Well, depending on how far we run on the shore, we're going to approach the, what is it, a ball? A stick. We're going to approach that from a different angle. Like assuming the angle is at the stick, if I run a full 15 feet on the beach,
It's
that
true.
would be angle
It's not the,
zero.
that's not the answer I was hoping for.
Well, the angle somewhere else.
What kind of shape is that?
That's a tree angle.
What kind of triangle?
That's a right triangle.
What's the law for right triangles?
Hypotenuse is the longest side.
True.
And aside from the right angle, the two other angles have to add up to 90 degrees.
Well, that's just because of triangles in general.
Okay. No angle can be above 90.
That is not necessarily true for all triangles. For a right triangle, yes, but again, that comes from a law of triangles, not just right triangles.
Wait, you want a right triangle or
Pythagorean theorem.
Okay.
Sum of the square of the sides is equal to the square of the hypotenuse.
That's right.
What's the hypotenuse?
S.
What is the height, which is one of the sides? What's the base? Quantity of 15 minus x squared plus 30 squared has to be s squared. That's the constraint. Which allows us to solve for s. Or x, whichever one you want to do. X is going to be a bit more of a headache.
Could I have done a different constraint with like some trig things to solve for S?
What trig would you, I mean, like, theoretically could,
Okay. I don't want to.
but that's going to make it a lot worse because now you're dealing with angles.
Yeah. This seems better.
What do I want to do? going to write x in terms of s or s in terms of x.
Well, I feel like we could write S in terms of S if one of these then wouldn't look good.
They're both not going to be fun. However, I think in the long run, that's probably the best option. Solve for x in terms of s. So we can write time now strictly as a function of s. What is the smallest s could be?
30.
Can't be any less than 30. What is the largest s could be?
I'm going to say also 30 because, no, okay.
Square root of 15 squared plus 30 squared.
Which is 15 root 5. The dog could just swim the entire distance. Which would then form a right triangle with base 15 and height of 30. So it would have to be the square root of the sum of the squares, which winds up being 15 root 5. T prime. Quotient. Quotient.
Well, that could be a constant multiple of 1 over 22.
They really want this.
I would not be using quotient rule here.